Example number 3, to find the Laplace transform or find the Laplace of the periodic function. In this example, we have a periodic function. One period is equal to 2. Here to here. This is one period. So take note that the Laplace transform of a periodic function is given by the Laplace transform of the first period over 1 minus e to the negative es. Now let's get the expression for the f of t of the first period. So f1 of t is equivalent to, we need to get this equation. We have mt plus b. So this is from u of t up to u of t minus 1. So u of t minus u of t minus 1. So our slope is 2 over 1, or it's equivalent to 2. Next is we need to find the value of b. So when t is equal to 0, f1 of 0 just 0. So solving for b, we have 0 equals to 2 times 0 plus b. So we have b just equivalent to 0. So our expression for the first period is 2t u of t minus u of t minus 1. So distributing 2t, we have 2t u of t minus 2t u of t minus 1. So this term right here, we can directly get the Laplace transform. But this right here, we cannot get the directly the Laplace transform because we need to transform this in the form of f of t minus a u of t minus a. How do we transform this this term right here into this? Let's just copy this first term, 2t u of t minus 2. What we'll do is we subtract 1 from this t right here, and then we add it by 1. So this becomes t minus 1 plus 1 u of t minus 1. So this expression right here, even though they are not the same, if you look at them, they are not the same, but they are just equal. If you simplify this equation, this becomes 2t. Next is we need to group these 2 and then multiply u1 of t, u t minus 1. So this becomes 2t u of t minus u of t minus 1 u of t minus 2 u of t minus 1. Now we can get the Laplace transform of each term. So the Laplace transform, the first period equivalent to, we have this 2 over s squared minus 2 e to the negative s. So we have a time shift over s squared minus 2e negative s over s, or this is equivalent to 2 over s squared times 1 minus e to the negative s minus s e to the negative s. So finally, the Laplace transform of this periodic function is equivalent to 2 over s squared times 1 minus e to the negative 2s times 1 minus e to the negative s minus se to the negative s. The next example is find the initial and final value of the following function. So we are given g of s equal to s squared plus 2s plus 6 over s quantity s plus 1 squared times quantity s plus 3. So the initial value property says that g of 0 is equal to the limit of s times g of s as s approaches to infinity. So we have g of 0 equal to the limit of s g of s approaches to infinity. We have s times this function squared plus s cubed plus s2 plus 6 over s plus 1 squared times s plus 3. S cancels out. Now, if you take a look at the value of s, so s approaches infinity. So we need to transform, or we need to manipulate this equation right here so that s will be the denominator of each term. Because we know any number over s when s approaches infinity is just equivalent to 0. We have limit of s s cubed plus s 2s plus 6 over s plus 1 squared plus s plus 3. So we need to factor uh, s cubed in its numerator. We have s cubed 1 plus 2 over s squared plus 6 over s cubed. Then the denominator we have expanding this term right here and then factoring out s squared. We have s squared 31 plus 2 over s plus 1 over s squared, and then this term Factoring out s, we have 1 plus 3 over s. So s cube cancels. So we are left with this. So if s approaches infinity, this becomes, we have 1, this term, when s approaches infinity, becomes 0, and then plus 0, over 1 plus 0 plus 0 times 1 plus 0. We have a value of 1. Now for our final value, we have g of infinity equivalent to limit of s of g times gs, g of s approaches to 0. We have s times s cubed plus 2s plus 6 over s times s plus 1 squared times s plus 3. Now substituting 0 to variable s, we have 0 plus 0 plus 6 over 0 plus 1 squared times 0 plus 3. We have final value of